So review for Chapter 9, Logic. On the test, you will have to be able to translate between verbal and symbolic. You'll need to know all the symbols that we have. You'll have to be able to fill out truth tables. You also need to know inverse, converse, contrapositive, all those types of things. So we have our P's and Q's. We have an and statement. Which has a mistake on it. Where's the mistake? This one should be false. And not P. That should have been true. I don't know what happened there. P or Q. We're looking for at least one true, so this would have been true. And this one would be false. P or Q and not P and not Q. Well, they've already filled in that one, so we don't have to worry about that one. Oh, which tables? 2 entries that are incorrect. So there we go. That's what we were trying to find. Well, I found those. Circle the 2 incorrect entries. So we found those. Fill in the missing values in column 5. We've done that. How would you describe the statement? I should have read the instructions. How would you describe the statement represented by the values in column 6? So what do we call it when we get all falses? That's a contradiction. If it was all truths, it'd be a tautology. Number 2, complete the truth table below and explain its significance. So I'm making sure I read the instructions this time. So the double arrow is if-then. So the only time if-then is false is if you lie. Okay, so P to Q. So true, true, true. True, true. True, false. That's when I lied. True, false, I lied. If the first part is false, it doesn't matter what happens next because Q only relies on P being true. So all of these are actually true. The next one, Q, then R. So if Q, then R. So true, true. True, false. False, true is actually true. False, false is true. True, true. True, false. False, true, and false, false. Our next column is not R. That means I take every value in R and negate it. So if it's true, this one becomes false. False becomes true, and so forth. So it's going to flip those signs. So now let's see what this next statement says. If P then Q, so this column, and this column, and the last column. So they're all connected by ands. That's a weird one. So when it's all connected by ands, we're looking for when they're all 3 true. So true, true, false. Nope. Nope, not there. Not there again. Not there. Not there. The only one that had all false, all trues is here. The next column is not P. So I'm supposed to take column P and negate it. Let's double check that last column. We're supposed to take this triple and statement implies not P. So if this happens, then this needs to happen. So if that doesn't happen, then it doesn't matter. So all those are true. And true, true would be true. Explain its significance. If you end up with all true statements, that is a tautology. Number 3. So we have Alex is from Uruguay. Alex is a scientist. Alex plays the flute. If Alex is not a scientist, so not Q, then he is not from Uruguay. If Alex is a scientist, then, ooh, this is interesting, he is either from Uruguay or plays the flute. Uruguay or flute. Write the following argument in words. So that double arrow means it's an if-then. So I'm going to start with the word if. This first part is my if, so not are. If Alex doesn't play the flute, then it is not the case that Alex, Q and P, is a scientist or is from Uruguay. This is the most precise way to do it, is to add that it is not the case that, and then write Q or P like you normally would. Number 4. You can definitely tell this one came from an IB test. Let that weird symbol equal X such that 1 is less than or equal to X and it's less than 17. X is an element of the fancy N, which is our natural numbers. P, Q, and R are subsets of that. Ooh, okay, so the fancy thing, it wants me to list all the elements. So that'd be a curly bracket. So that would start with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I do not write down 17 because it does not include it. P intersects Q intersects R. What we're looking for are things that meet all 3 conditions. They're subsets of this. So P says we're multiples of 4. Okay, so I'm going to narrow it down. The next ones are factors of 36. That one's a factor of 36. That one's not. That one is. That one's not. And R is they have to be a square number. So this is the only thing that meets all 3 conditions. Describe in words the set P union Q. So the union is an OR. So if we look at that, that would be multiples of 4 or factors of 36. Draw a Venn diagram to show the relationship between these sets. Now notice this would be a paper 2 question. Well, no, this one wouldn't. But you would have room to actually draw this on your paper usually. So I'm going to draw my Venn diagram, P, Q, and R. You want to label them. And since this one, they're subsets of this fancy, I don't even know how to draw that, I'll try, then that's going to be our universe. Now it says to write the elements in the appropriate places. Well, we know 4 goes in the middle because that meets all of them. Okay, so P was multiples of 4. And then, okay, Q is the factors of 36. Well, 4 and 12 were the only ones that met both requirements. This one has to be 12. Let's see. R is square numbers, and then factors of 36. So 4 is already there, factors of 36. 4, 6, 9. would go there. Okay, so multiples of 4 and square numbers. Multiple of 4 and a square number. So 4, 8, 12, oh, 16 is another square number. It would go there. So now, I need all the other multiples of 4 to be listed here. So we had 4, 12 is already listed, 16 is listed, 8 is the only other multiple of 4. The other easier one to do is going to be the squares. So, perfect squares. 1 is a perfect square. Actually, 1 is also a factor of 36. I should have put that in there. 1. Perfect square, 9. Oh, so that's it. There's nothing in there. Other factors of 36. 2, 3. And 6 doesn't go in there. Yes, it does. 6. That looks like it. So the ones that are on the outside are 5, 7, we already got 8, 10, 11, 13, 14, and 15. Those do not have a place in P, Q, or R. Now, they switch them to lowercase letters, and then they start using symbolic logic. So write a sentence in words for this statement. Now, there's not much room there, so let's kind of talk through it. Those are in parentheses, so that means that's together. So, P is either a multiple of 4 or a factor of 36, and not, oops, I'm sorry, P was multiple of 4 or a square number, and is not a factor of 36. So shade the region on your Venn diagram that represents that. So P or R would be all of this, and it's not in Q. So we're talking about everything that's in P or R, but not in Q. So now the first 3 tables of a truth table, listen here, they've got P, Q, and R. Write the first 3 columns. And now we're going to do a truth table to do that. So let's go ahead and start with the part that's in the parentheses, P or R. So we're looking at the column P, column R. True, 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 false, true, false. Now I'm going to write the column not Q down so that I can compare it to that grouping. Not Q would be false, false, true, true, false, false, true, true. Now I'm going to combine those 2 columns with the conjunction and. So I'm going to take P or R and not Q. So, and they both have to be true. So false, false, true, true, false, false, true, false. Write down one possible value of X for which that's true. What about, if we look at our thing, what about 8? Is that a multiple of 4 or a square number and not a factor of 36? It is.